participants. Okay. Okay. So I think we reached out to this topic in our last session, which is NumPy. So NumPy is an built-in library which provides us help in terms of working with the 1D arrays or 2D arrays. So as by definition, it provides support for arrays and matrices along with a collection of mathematical functions and data structures which can more enhance. So whenever we talk about in LLMs, we call embeddings, right? So we are talking about basically array. So that array could be one dimensional or two dimensional. And there is something called as batch inputs and matrices. This is a little bit more advanced, but you can assume it like 2D arrays. So for simple operations, we can use 1D array, and for a little bit more complex operation, we can go with 2D arrays. So arrays vectors are just represent single token feature, and matrices enable batch operation feature. So basically, this is typical array which you might have used in your other programming languages, or you might have studied matrices in your bachelor's or high school. So these are simple those arithmetic operations only, but in Python we call them or we use them through NumPy. Okay. So by default, usually you will have this package, but just in case if you do not have and you want to install IPY within the IPY file, so you can use this. Okay. So how we can, because it's an external functionality, not a part of the normal Python which we use. So we can use this import function which will help us import this NumPy, and we are calling it as giving it as alias. So we understood this in a greater context and detail in our packages and module section, if you remember. So we are just importing external functionality, and we're just giving it a name as NumPy. So what we understood here was how to initialize an NumPy array. So this is my normal variable. So what I'm doing, I'm using this NP, which I've used as an alias, so mp dot array, and then I'm giving here a list. Okay, this is a one dimensional initialization of a NumPy array. So when I do this, my ARR1 will have the details. If I run it, if you see, ARR has these details. So this is what this is just an initialization of an NumPy array in one dimensional. So if I want to make this as a two dimensional, there are two ways. So one is like you can give this additional, you can just add more brackets here manually and just give another list as an input to this array. So this is a manual approach. So this will create a 2D array. Or there are certain functions like reshape, which we will discuss later in this IP1B file. So to create a 2D array from 1D array. So if I initialize this and print this, if you see, this is two dimensions. So information is represented in two dimension. So I'm not sure if we have a vector embeddings. If I have an image which could show object as vectors, maybe this image. So if you see this information 0.6, 0.3, 0.1, all these are vectors. Okay, we can, I mean, so basically what is happening is these are inputs. So computer does not understand it the way human understand. Computer understands mostly numbers. So you give images. Okay, sorry, I just got disconnected, I guess.
Kapil, we have a trouble hearing you.
Can you hear me now? Is it okay?
Yes, now we can hear.
Can I have a folder? I don't have it. Folder? Which folder? Okay. So I was just trying to explain you the significance of arrays or vectors or matrices which we have in which we use in our whenever we are creating and RAG based application or we are working with the LLM. So this is a kind of a thing which is called as behind the scene. So behind the scene, your images, whenever you upload something into your chat GPT or Gemini, right? So that information is not visually directly understood the way we as a human understand this, because computer understands or rely on numbers. Okay, so it wants all the details which is present in images, documents or audio in form of number in such a way that two two numbers can be compared. So as a normal human, if I say if I say someone ages 10 and someone ages 12, so as a human we can compare this, right? Maybe this is, let's say 2. So we can compare these ages, right? So how we are comparing? We are comparing which one is less and which one is more. So based on that we can tell who is younger who is older. So in the similar format, computer also needs numbers, so they will try to represent all the information which are there in images, documents or audio in the form of numbers. So for to convert these images, documents and audio in form of numbers, we use embedding models. Okay, so these embedding models, what they do, they represent the information whichever is present in this image, document or audio into these objects which are vectors. Vectors are nothing are arrays. If you see,
So why we cannot use tuples over here?
sorry, what was your question? Why we?
We already have like tuples in the Python,
Mhm.
but why we need to use these NumPy arrays?
But tuple, when we operate, so tuple doesn't have I mean tuple doesn't allow information to be represented in 2D 3D or more than that. So we want, so actually when you work with tuple, right, you are working only with 1D type of a thing. You cannot work with 2D operations. And there are certain operation in which we want to, so if this is just a one information, just two information or small information means let's say age, employee ID and this, when we work, let's say 100 or 500 information, if we are using that for tuple for comparison, that might work. But when we have huge set of information, I mean this image can be of 64-bit, 32-bit, 10-bit. So there are, and this document, so when the representation or the information which a document possess is lot more, and we want an application, because we want to capture a lot of information every, so even the color, this color has a perfect is there a website color color picker, I think this is the website. If you see this information is also represented in form of numbers, right? So this information is also represented in CMYK, RGB, HSV and HSL. So when we have a lot of information, it's very difficult to work with tuples. So we need something which could hold this information, and we should be in a position to compare them easily. So that's why I mean this is from the data scientist itself, though they went through this approach where we where they found, like, I mean when they can try and work with arrays, so it's easy to compare two informations of related or unrelated objects. So whenever you give, so if you have seen a image recognition system, so let's say you are working with an police or any agencies which want to recognize a particular photo, so your facial expression and your photo will have certain points and certain information, so that information will be compared from this database, and based on the match they will produce an output, like it's a 92% match or 80% match. So this particular task will not be possible through tuples, because I want to store a lot of information about you, a lot of information from the picture. So tuples do not scale that well, or the arithmetic operations which we can perform with vectors and matrices are not possible inside tuple. For smaller data, it's okay because those are faster. But for huge data set, when we want to represent, you can say highly complex objects, then right now this is the technology which will represent information in this objects and vectors. But as we move forward, maybe after 5 years, we might have completely different architecture. Okay. But the basic fundamental things will remain same. We have to extract the information from here, which could represent in terms of numbers. Okay. We might be using some different arithmetic operations to make our predictions faster, but the fundamental thing will remain the same. We have to represent this in the form of numbers. So data scientists came out with this approach where they used 1D or 2D arrays, or we can say matrices, to represent the information which is present in any of the type of document which you are inputting here. uh, if you see in today's embeddings are typically used in this easier to, I don't know if they have given any kind of a reasoning behind this. Okay. Did I'm not sure if I answered your question perfectly.
No,
uh,
it's okay. I got the point now.
yeah, so basically the,
Basically,
yeah,
tuple is just for normal calculations, or
yes,
but this is for big picture.
yeah, yes. I am not getting that image. If I can show you, yeah, if you see this one, where is okay, so okay, so maybe this image might give you some sort of idea on how we are representing. So whenever we are representing any item, whether it's living or non-living, so we are representing information in multiple parameters, positive values also, negative values also. So if you see from image, we are working on 7D. So if you see dimension reduction of words embeddings from 7D to 2, so we have 7 dimensional information, and we are just, so what they are doing, they are just converting into 2D for easier calculation, for easier comparison. So this is how we try to represent, although they have represent in a single 1D kind of an array, but but if you see here, they are taking as a 7D. So in chat gpt or any other llm model, your information is huge. So maybe this point 6 is representing about the dog color could be white, black, anything. Maybe this point 7, maybe this is representing it as whether the dog is smiling or its facial expression, like that. So when we have to work with the multi-dimensional data, so we use arrays and vectors comes in handy. So what this guy is trying to do is this, these are the words, these are just the words, these are its embeddings, and then it representing dimensional, I mean it's using an approach where it converts 7D to 2D, and it's visualizing, so how machines are understanding. So they are doing some calculation, they're keeping house as here, puppy as here, dog as here, so it's trying to compare. Now it's man is compared to a woman, king is compared to a queen, and based on that it can give you a response. So a lot of comparison will happen, and based on that, because we are also doing comparison every now and then. When I show you this screen, so your brain is also processing this image, right? So you are also doing a lot of comparisons. Okay, what is this written, what is this written, what is this written in your brain? But in a similar format, machines also understand a particular thing in terms of comparison only. They do not understand the way we are doing typically. So like that. Okay. Okay. So this is another one-dimensional array, just the same example. And if I want to convert this one-dimensional into two-dimensional, I can use a function which is called as reshape. So reshape this one-dimensional array with one row and five columns. So if I now run this, so this one-dimensional array is converted into two-dimensional array. How can I say that? Just if I just increase the manually, if I just provide additional brackets, right? So then it tries to consider it as a two-dimensional array. So this 1 2 3 you can assume as this information. It's just that we are providing this manually right now. Okay, later we'll see how we can generate this information. Okay, so this is another example. Yeah, so here we understood how to use reshape. uh, so reshape will convert your one-dimensional array into two-dimensional. And once you have a 1D or 2D array with you, if you want to know its shape just means what, whether it's a one dimensional or two dimensional. If you check the shape of a 1D array, let me comment this. Let's say your input array is this and your shape is this. If you see how it is represented, it's representing 5 comma. So this is an example of 1D array. If I do like this, if you see, it's a 2D array, 2 rows and 5 columns. You can understand like that. So shape will tell you the dimensions of that array. That's it. Yeah. So this is just to generate an normal array. So a range, it's an array range. It's similar to the range function which we have used earlier. So this is kind of a start, this is kind of an end, and this is kind of a jump. So if I print this, I'm getting this. So if you see, I'm starting from 0, then I'm jumping. I left 1 and then I reached to 2, 4, 6, and 8 in the similar format, and then I'm just printing the shape because it's a 1D array. I'm not getting the I'm only getting the 5. Like, I mean, you have only 5 elements. You do not have a second row in this. So that's why. So if I try to reshape this, okay, 1 minute.
Kapil, your screen is stuck and we can't hear you neither.
Maybe he lost connection. Okay.
Yeah, probably.
Copy. Yeah, I think he lost connection.
You can get this from GitHub. Can get this from GitHub. Is it not there on GitHub?
Kapil,
Uh-huh.
Kapil, we
Yes.
couldn't hear you for like a minute.
Is it? Yeah. I just went. Uh, I just went for drinking water. Am I?
Okay.
Are you able to hear me now?
Yeah, sure.
Okay. So this is it not present on GitHub? Yeah, it's there, right? So I mean, you can clone it from here. Okay. Still you have any challenges? I mean, we can connect at the end of the session. Okay, where was that? Okay, 1 minute. Let me just exit this. Okay. Participants. Okay. So so whatever we have created an array here, we just use a reshape to convert it into 2D. And when we convert it into a 2D, so it's like 5 rows and 1 column. We converted like this, and we got an output here. Okay, so we are just using it and getting the output. We are not doing anything complex here as of now. And whenever, even though when we will be working with projects, right? So this whole generation of these properties, these numbers, will be done by an embedding model. We will just create the flow. Like we will create how we can store these objects, and then how to connect this with an embedding model, and then how to store this information. Okay, we will not directly generate this. If you want to go directly generating this, then we will have to go more deeper into machine learning algorithms. Okay. So np dot once will create an NumPy array. Okay, so so what np dot nums is, it will create an matrices, 2D matrix, which will have all ones in it. Okay, so we can create 4 cross 4, we can create 5 cross 5 also. I mean, as you want. So np dot I, it will create an identity matrix. You can create for 3, you can create it for 4. It depends, I mean, based on the use case. So what it will do, so diagonally you will have ones. Okay, in an identity matrix. So it's a mathematical name. Diagonally you will have 1 and rest will be 0. So in some operation, when you are comparing this with another, so there are certain operation like transformation from rows to column and column to rows. In those scenarios, you might need an identity matrix first initially, and then you will perform certain operations. So in those scenarios, we might have to, there will be certain operations where we might need to use these, but just to understand the behind the scene of the machine learning, we are doing this. So now np dot array, when we gave our to list here, to information of to list here, now I'm just printing the I mean, whatever the response I'm getting from this line here, then the shape, and then the dimension. Okay, so because it's a 2 dimension, then the size, number of elements, and the data type. So this can vary based on a platform, and this also may vary, item size may vary based on your platform. So this is just the information, just the typical information from this particular NumPy array, nothing more. So Shoaib, you already know this is just a printing this element. Dimension is whether it's a 2D or 1D. So if I make it as a, no, even if I reduce the okay, size is just the number of elements, and data type, it could be int32 and int64 also in some cases based on the platform. And item size is just the size of the elements in bytes. So it's a 4 bytes, whatever you have written. Okay. Yeah, so these are just normal operations, uh, like how you can perform an addition. So you give the information, and you create an instance, I mean, you create a variable, one variable, and you create another variable, and then you perform an addition. You can perform a subtraction also, you can perform a normal multiplication also. So each individual elements, these operations will be performed. Like the addition, 10 plus 1 is 11, then 20 plus 2 is 22, and so on. The other operations are also performed on each individual elements of this array. So these all arrays and these all array operations are done by the, where was that image? Yeah, this image, done by the machine, to understand the difference between dog and puppy and cat and house. So all this calculation, all this comparison is done behind the scene, so that machine can compare, because machine doesn't directly understand, right, what is a dog and what is a puppy. So it has to compare it. Okay, then this was array slicing and indexing. So I will not go very deep into slicing and indexing. because we have already passed 40 minutes. But just to let you know, so this is at 0th level, this is at first level. I mean, this is at 0th row, this is first row, and this is second row. So, and this is my typical array. So I can reach out to a particular object. How will I reach out to a particular object? Based on this slicing. So this first element will tell me from where to start. This is a kind of a where I want to reach as a row, and this is on which row I want to perform what kind of operation. So first means what? First means this row, and in this row start from first. First means start from first means I have copied this here. Yeah, start from first, because here it's 1, right? So start from 6 and end minus 1. 3 minus 1 is 2. So this is 2. So in the similar format, we we are doing the operations because there is no endpoint here. So we printed the elements of next row also. So these elements also got printed 10, 11. Okay. In this also same example, you have a row here. So this before the comma, this is representing a row, and after the comma is also representing sorry, before the colon it's representing the row, before the colon is representing the particular, before the comma it's representing a row. So this complete represents a row, and this is representing the column. Okay, so you can separate it through comma, and then once you approach to this, based on the you have to start it from 0 and end it at 2. So you'll perform on the particular row, and then these, taking these value into consideration, you have to perform it on column, which column it is. So if you if you consider this is 0th row, this is first, this is second, and in terms of column, this is 0 column, this is first, this is second, this is second. Okay, okay, this is also this. This is also the similar operation. I'm sorry, my throat is not well. Okay. Okay. uh, these are also just the logical operation. So given this is my input, I can get the output as whatever the elements are greater than 5, and also those are less than 8. So 5 is greater than equal to 5, and up to here less than equal to 8. So this is all about NumPy. Okay, now let's go to Pandas. Pandas is a kind of interesting module. Okay, so it's a powerful data manipulation library which is available in Python. Okay, so for data analysis, data cleaning, we can use this. So if you see, it says it's a series of one-dimensional array-like object. So in Pandas, whenever we talk about data frames, so data frames are two-dimensional objects, and whenever we will talk about series, so these are one-dimensional objects. So if I want to work with Pandas, because it's an external functionality, I just have to use import Pandas as PD. So PD is just the alias of it. So here I just imported this here also. Yeah, I mean this is just a repetition. We can delete this. Yeah, keep it on. So I took a sample data here as in the, and then I created a variable which is called as a series. So pd.series. So it's an inbuilt function within the pandas series, and I'm just using this data to create a series. And then when I printed this data, so if you see, we have series of data. Okay, 1 2 3 4 5 6, we have a series. I mean, this is just the first one is the index, like it's a zeroth is the first data, second data, third data, like this. So you might say, I mean, where do I use this series? So we can send this series data from one destination to another destination. Sometimes there is the challenge of bandwidth. So if I consider mm, yeah, this one. So if I try to send the whole data at once, and my wire or this pipe capacity is not that, so then I will be constrained within the limits of bandwidth of that pipe. But if so one way is I can increase the size of the pipe. The other way is, if I want this constant flow, what I can, in this way you can understand what is Pandas series. Okay, so if I print type of series, you will get it's from the class is from Pandas. Usually Pandas we work with I mean, CSV files. We will see. I mean, I think this is in that working with CSV file in this 9.3 section, but we will cover for first initial basics here. So let's say we have a normal dictionary, which is A is the key and 1 is the value, B is the key, 2 is the value, in the similar format. So if I convert this data into a Panda series, so what will happen? This variable will have input from this. So if I run this, you see how the data is converted. Your left side you have your elements, and right side you have your, I mean, let's say left side you have your keys, and right side you have your values. So this is representing a Panda series. Now let's say your data is this and your indexes are this. Okay, we separated this. I mean, we are taking a list example here. Your data is 10 20 30, your indexes are abcc abc. So in pd.series, what we can do, we provide the data here, and then index is equal to index. If I go here, if you see, I can provide the data here, and I can provide the indexes also, index also. So what I'm telling, whatever this function accept internally, value of that function is this thing. So then if I print it, if you see a b c, and your 10, your 20 and 30. So if you see, slowly when we move forward, so you will understand in Pandas we are working in a similar format which we work in Excel sheets. Okay, slowly we'll see how to work with Excel sheets as well, because our lot of data will come in the form of Excel sheets. So now so this was all about the series, Panda series. Now when we talk about two dimensional, so we talk about data frames. So this is my data. Okay, so this is my key and this is my value. My value is in the form of a list, and this complete is in the form of a dictionary. So inside dictionary, I'm using this as a key, and the values are in form of a list. This is my key, the values are in the form of list. This is my key, and these are my values. Now uh, earlier I was using series to convert it into series. Now I'm using data frame. So as soon as I try to print this, right, in the data frame segment, so yeah, print df, yeah. So this output, if you see this name, age and city, name, age and city. So this is, I mean, this is the similar. If you go here, date, category value, product. So in the similar, which we can see in the actual sheet, we we can generate a data frame here. So when we printed this information, so this information was represented in the form of a data frame. Okay, so now this is not a dictionary. So if you print the type of, let's say you try to print off initially when you try to print the type of data, you see it was a dictionary, but now we converted into a class of Pandas. Okay. Now let's understand the concept of log and ilog. Okay. So let's say we have this data. So we did nothing. We just this information. This is the way we collected this information. We are giving this information here. So these are your kind of column headings, and this is your data. And here we are telling the index is equal to row 1, row 2, and row 3. Because here we took it as a dictionary, but here I'm manually giving a complete data frame. Okay, so this is complete a data frame. Here the output was a data frame. Here in the input itself, I'm giving the data frame. Okay. So if I print it now, you see my row names are here, row 1, row 2, row 3, and my column names are here, and the in between data is printed here. Okay. Any doubts so far? It's not good.
What is data form?
Sorry, data form, data frame.
Yeah.
Let me go to. So data frame is just the two-dimensional. I mean, in simple terms, it's just information which you can represent in the form of rows and columns. This is just a very basic information. If you go by definition, so it's mutable, it's heterogeneous, it's a tabular data structure with labeled axes, rows, and columns. In your Excel sheet, your data is represented in the form of rows and columns, right? So in the similar way, in the data frame also, your data is represented in the form of rows and columns. Did I answer it, or you have?
Yeah, just got it.
Huh?
So we use pandas basically for like displaying the data.
Yeah, right now we are learning displaying and playing around with basic data, and later we will use pandas to manipulate the data. Manipulate means, let's say there is no information here. How to handle this through pandas and how to read a particular CSV. So all these operations we will do with pandas. So if anyone asks you, I mean, why we are using pandas, so the general and simplest answer is to work with CSV files, to work with data frames. What are data frames? So whenever we are trying to represent our data in a tabular form, in the form of rows and columns, so that is what a data frame is. Okay. Okay. So let's did I answered Yashlok? It's okay, right? Or you have more doubts?
Yeah.
Okay. Okay. Yeah. So then there are two concepts which is called as log and ilog. So log you can understand as a location. So your data is located at a particular row, at a particular column, right? So let's say if I click it here, you see it's telling it's at F4 place. How do I know it's at F4? Because if I go to F column, 1, 2, 3, 4, it's at fourth position. So by looking at like this, so and like this, so I'm navigating. Or if I say if I need to reach to 32, I have to look from the column perspective as well and from the row perspective as well. See this, if I say like this, and if I say can I color, let's say I color it to some. So if you see the intersection point, so this particular thing is my intersection point. So in order to get to this element, I have to go to the fourth row and the C column. So this is my intersection, right? So now my cell name is C4. So if anyone says me like C4 has certain values, so now everyone understand in C4 there is a 32 value, in C5 there is a 8 value. But how am I reaching to this point, to this conclusion, whether this has a value of C5? Because I went to the C column and then the row number was 5, so C5. Okay, so now if I go here, so log and ilog both will give you the the location of the element, the value of the element which is present at that location. But there is a different in terms of the perspective how log and ilog is giving the values. So if you see here, this is my I mean, you can forget this. This is my data which is given in the data frame in the form of rows and columns. If I want to get to this element 50, so 50 is at the center. So how do I get? I have to look from the B column and the row 2. So row 2, if I go to row 2 and in B column, I will get this element, right? 50. But I can say it in another way also. 1 column 1. This is what? This is my 0th row. This is my first row and this is my second row. In terms of numerical positioning, you're getting, if I copy this, can I, let's see if I can copy this. Hmm. This is 0. And one more. This is 0. So if you see, uh, in terms of numerical positioning, where is 50? 50 is at first row, first column. But if I call it by values of columns, columns or row identities, these are labels, right? These are just labels. My actual data is in between. So if I use by the column name my B column and my row 2, then also I'm able to reach to the same element. So when you want to extract the value of the element through the labels or the column names or the row names, we can use log. But when you want to capture the value from the numerical positioning, we can use ilog. Okay, both will result into same. If I run this, right, see 50, and if I comment this also results into 50. So this is what we need to understand. Okay, this is okay. So now in terms of slicing also, let me just comment this in. So if you see, start from row 1. You remember slicing, I think here also, if you remember this calculation, these are nothing but slicings. Okay, I have to start from row 1 and end at row 2. And I'm using labels. Okay, I'm using labels. So row 1 starting, if I started from row 1, so row 1 is this, and I ended at row 2. Okay, simple. And if I comment this, if I go by positioning, start from 0 and end at 2 minus 1. Start, if you see, start is 0 and is 2 minus 1, which is 1. So start from, start from this and end at this. Okay, so this is just a row slicing. So there are two perspective. Okay, one is by labels, one is by position, numerical positioning. Then in the similar way, we can do column slicing. We didn't give any information for the start, but we want A and B. So if I run it, so A and B columns are represented. So I am now telling directly through the column names. Okay, referring through the column labels. But here what I'm trying to do is through position, numerical positioning. Start and end minus 1. So this is, I'm not giving anything here. So everything will be captured. And this I have to start from 0th column. 0th column is what? If I go here, 0th column and end at 2 minus 1. So this is, okay. This is how it is. Okay, now, so this is the sales. Where is sales? Yeah, okay. And this one is what? This one is only data. Okay, let me try to open this. This is so if I directly open the data here, it's in it's not you can say in a good format, but if I directly show you here, so this is the data. If you see, you have a transaction, you have date, you have a product category, product name, unit sold. So this is the data which we have in our Excel sheet. And remember, this is in CSV format. So usually we work with CSV format data because it's easy to separate elements. There are multiple formats when you try to save a Excel sheet. Okay, there are Google sheets also. Okay, and there are other third party sheets also, but we are primarily working with CSV format data. Whenever you download a movie or a song, so your song has MP3 format, then your movie can be MOV, MP4, like that. Different formats are there, right? So we are primarily working in corporate also. We primarily work or rely on CSV data, not any other format data. Okay. So this is my input data, and now I'm trying to yeah, so I'm using input function. So this is my data frame, pd dot read CSV function. Okay, so this will read the data from here. Once it reads, so I'm just using a function with this. So this df is representing a data frame. Okay, so I'm using another function, df dot head, and this is my 3. So 3 means top, head means from top, right? So from top, so from top, give me 3 results. If I say from top give me 5 results, then from 0 to 4 it's 5 results. If I say only give me 2 results, so if you see, yeah, we have only 2 results here. Okay, so similarly, I have tail. So head to print the top results. Okay, by the way, I can show you top results here. iPhone 4, Dyson V11 vacuum. So we have here the top results, and tail is the bottom results from bottom. Okay, from bottom means tail 3, last three data. If I want to display it here, last 3, if I go, it's big. Handmade this Yeti Rambler, Sunday this and this. Okay, so these are last 3. That's it. So accessing data frame, accessing data from data frame. So let's say I want product name. What is my product name here? This is my product name column. I want data of only product name column. So df and then the column name. I'm just looking here. Okay, just searching it. So if you see iPhone 14, this Levi's and this and that. So this particular data is extracted from there. Okay, here. And then I can use because now I have the data. I have created this data frame variable here, which have all the data in this variable. I can use location also. So on 0th location, what data do I have? I have this data, which is the row in your data frame. If I print the type of this data, it's pandas class. So let's say if I print location first, yeah. So 0 is this data. If I go to this one is the transaction. Okay, so this is 0th data which I'm getting here, 101, and then this date. Yeah, this row, I'm getting this row here. If you see this row in column format, this is this and this, and then electronic arts and iPhone, then 2, this electronic phone and 2. Okay, if I go to second, oh sorry, first, then if you see it's second row, this one home appliance Dyson 1, uh, this home appliance Dyson vacuum 1. Okay, in the similar format. Then in the similar way, I can use iLog also to represent to print the data. Okay, first row the data frame of the Panda series. So even, I mean, you can try with 1, 2 here. So these are mostly similar. It all depends on how you want to access the element. So now there is function which is called as at access a single value for a row / column label pair. So I want to access iPhone 14 Pro. Okay, before that, let me try to show you the data itself. df dot head head so this is my data. Okay, I have this data. Now if I thought this is my data, okay, and if I want to print iPhone 14 Pro, I'm at the 0th row and in product name column. You see the intersection for this product name 0th row. If I do it 1, Dyson 11 vacuum, Dyson 11 vacuum. Okay, in the similar format I can use at. So this is for same example from the product category. If I do it 1 product category, see home appliances. Okay, access a specified element using IIT. IIT also gives you, this is similar to iLog in that provides integer based lookups. Okay, if it's at let's first try with 0, 0. So this is 0 and 0th row, I mean 0th column and 0th row. It's skipping the what do you call first column, because these are column labels. Okay, my actual data is below the column. Okay, so what is at 0, 0? I have this data. Okay, and then if I say what is at yeah, if I want to 1, 0, see my next data came up. So this is my 1, 0. This is just df.head to, yeah. Now if I want to create a data frame from a list of dictionaries, so assuming these are my this is my this is my list in which I have multiple dictionaries. Okay, I have a list of dictionaries. So I want to convert it into data frame. So dfpd.data frame, and then they always check your length. Yeah, you can I mean you can check the length before the assignment. So these are what name, age, and city. So if you see here, name, age, and city. So I'm using these as a column name. I mean in the data frame these are represented as column name. So it understood like this is the key, and I have to make this key as the column name, and then other elements are the values. So all other are values. Simple from dictionary to data frame conversion. And then if I want to add a column here in this given data, if I mean let's say this is my variable, right? So once I extracted this and converted into data frame, if I want to add a column name, so if I want to add a column name, I have to give correct number, correct set of values. Correct by, what do I mean by correct set of values? 1, 2, 3, 4. How many are there? There are 4 elements here. So I have to give the correct set of 4 elements here in order to make a balance. Because if I make it as an imbalance, right, it will produce an error for me. If you see here, length of values 3 does not match the length of index 4. So that's why I have to match this. Once I match this, I'm telling the another column name should be salary, and then I'm giving this list as an input to this, and then I'm just printing the data. So earlier my data was like this, but now when I'm printing it, it is represented like this. I mean the salary column added. Okay. Now if I want to drop, so I added here. So let's say later if I want to drop it, I can use drop and then the column name, and then I can give axis, and this in place is let me try to show you. If I not taking this, let me try to, let's say now if I, this is my original data frame. Okay, okay, two of them. Salary not found in access. Okay. Okay. Why is it not found? Yeah. So yeah, here it when I'm using drop function, so it dropped. Okay. So it dropped here. So your salary column is deleted. Your salary column is deleted. But is it deleted from my original data frame? Let's see. So df is my original data frame. See, it's still there. So if I do like this without using in place, okay, so it's deleted from the output, but it's not deleted from the actual data frame variable. So if I want to delete it from actual data frame variable, I need to use in place is equal to true. Now if I run this, okay, I ran this. Now what happened? What is does not found in access? Now if I run this, once this is ran, yeah, see, if I run this twice, right, I will get an error. Why I will get an error? Because this original df function has removed the salary. So when if I run it again, right, so this, because this salary column is already removed, if I try to remove it twice, so then I will get an error, because it directly changed in the original variable. So if I run this, if you see, it is changed from the original variable. Now if I try to drop a salary from this data, there is no column with salary, right? So it will produce an error. Okay, so now let's say I have data in this column, right? I want to just make them +1. Okay, I just want to add +1 to these individual elements. What can I do? df.age, the column name, then df.age +1, add +1 to these elements, and then print the data. If you see 33, earlier I was having 32, now 33, 34 to 35. Now what I'm telling, df dot drop 0th index. Okay, now 0th index means this one, first couple 33 Bangalore. Now if I try to do like this, if you see the remaining data is only presented, I mean it's only present, the rest of the data is deleted. Okay, John, Happy, Jack. Then this, yeah, just I'm reading another one, and just this is sales data.csv. Yeah, this one, sales data. I think I have opened sales. Yeah, same CSV. Okay, and then what I'm trying to do here is, let me just comment this. So in the transaction IT, what kind of a data I have? I have int 64. So 64 is just 64 bytes. 64 bytes of data I have. Okay, I mean transaction ID. So my transaction ID have integer type of data, right? My date has an object. So there is no direct type of date unless and until we use an date time function. Okay, so what is trying to represent it? All these elements are in the date column. These are objects. Then unit sold is an integer. Unit sold, so these are integer values. Then unit price, it's a float, so these are float values. Okay, and then region is also an object, and payment method is also object. These are objects. Okay, now if I do a function, use a function which is called as describe, so what it will do, it will try to describe. So this is count, just a count. Transaction ID 240. How many counts do I have? So yeah, it's 240. I have 240 rows. Okay, so count is representing me 240 here, 240 here, 240 here, 240 here. Then mean is a kind of an average. This is standard. So these are all arithmetic. What is the minimum value to have? What is the 25% of these values? What is the 50% of these values? What is the 75% of these values in these individual columns? What is the maximum do I have in these columns? All these are I can get it through a single function which is called as describe. Okay, so let me open the platform. Yeah. Any doubts so far? Okay. Okay, today I'm planning to cover only up to this topic because my throat is not that well. So if you have any doubts in today's class, so you guys can raise me. And I think someone was having a problem in terms of, I guess, accessing the GitHub code, I guess. So I think Marius, you were having some issue. So are you able to access it now? Hi, Chris. You have doubt?
Oh, no.
Okay. So anyone else has any doubt, so they can raise it, because uh, that's all I was planning to cover. I mean, I was planning to cover another one, but I think my throat is not that well. So yeah.
Hey everyone, hope you enjoyed our session at LWP Labs. For more videos like this, you can subscribe to our channel and contact the number for live classes. The future is now with AI.